Alright guys, welcome back. We're going to be solving another question from the second chapter of engineering mechanics statics, and we have these two forces that are acting on the handles of a pipe wrenches to constitute a couple M, and we need to express the couple as a vector. So we solved a question in the previous video about how to find the couple in 3D questions, and basically you have to check first if we have a couple, we have two forces that are equal, they're both 150 newtons, so that's good. They have to be in the opposite direction. We can see one of them is upward, the other one is downward, so it has the second, and they are non-collinear. We can see there's distance between these two, so it meets all the criteria for making a couple. And as we talked about, basically for finding the couple, we are looking for a moment, which is r cross f, or the cross product of the position vector and the force. So for that, basically we can go with the distance from line of action of one force to the others. So if you just go from this point to the other one, this is going to be our r. And if we want to write down our r as a vector, basically we're moving in these two directions. If we just make a right triangle, and same in here, that makes a rectangle. So basically we are moving toward that direction, and after that we're moving in this direction. So it has both y and x component. The x component would be this distance, and we just clean up so we can see. So that distance moving from here to here is basically what we have in here, 150. So 150i, and it's positive because we are going in this direction. And for the y component, we are also going toward the positive y direction, which is this distance, and it's basically 250 plus 250, or 500 j. That's our r. And f, since we are finding the moment about this point, this force will be cancelled out, and the direction of the other forces we can see is along z-axis, and we can just consider this as our positive z, so it will be negative 150. Okay, so the rest of this is finding this cross product, and should be able to find the moment. So I j k, the second row is the r, so 150, 500, 0, and 0, 0, negative 150. And let's just find this. So for finding the x, we're just going to cover this. We have 500 times the negative 150. That's going to be our I. We have a negative sign for j in the formula, so just keep that one in there. We're going to cover j. Again, negative 150 times 150. That's going to be our j. And for finding the k, if we just cover k, we have these two, which is basically 0, so there is no k component in here. So let's just calculate this, and we know all of these r's are based on millimeter here. So if we just want to find them based on millimeter, we can just divide everything by 1000. Same in here. That way we can get the moment in Newton meter. So all the zeros are going to cancel out. 5 times 15, 75 I, plus can cancel these two. So 15 times 15 is 225 divided by 10, so 22.5 j. And yeah, that's going to be the final answer for this question. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.